Okay, enough talk. Let's actually implement this language by creating an interpreter for it. So the eval function evaluates an expression in the language, represented as a scheme list. It computes the value of an expression, and the value of an expression in the calculator language is always a number. The eval function itself is a generic function that dispatches on the type of the expression, whether it's a primitive expression or a call expression. So the implementation, the code, is actually going to be on the left, and then we'll match that up to the language semantics that we just introduced. So here's the program. It says calc_eval is a function that takes in an expression. That expression will either be primitive or a call expression. If it's primitive, meaning the type is either an int or a float, then we evaluate it by just returning that same number. So a number evaluates to itself, according to the language semantics. And here's the lines of code that actually implement that fact. Otherwise, if it's the case that the expression is a pair, meaning it's a scheme list, then we get the arguments to the call expression by mapping the calc_eval function over the rest of the list. Now, what is this exp at this point? Well, it should be a list that starts with an operator, such as plus, and is followed by a bunch of other expressions that are the operand sub-expressions. So evaluating each of those gives us all of the values that are the arguments that we'll pass in when we evaluate the operator. And then finally, we're going to call another function calc_apply that takes the plus and applies it to the arguments. So a call expression evaluates to its argument values, and we get those argument values by recursively calling calc_eval on each sub-expression, combined by an operator, and this is exp.first is the operator that gets combined with its arguments using some other function, calc_apply, which we'll look at on the next slide. So what are the important parts here? We have a recursive call, returns a number for each operand. So an operand sub-expression could be some complex expression, a call expression, but we reduce it to a number by calling calc_eval. Calc_apply does the work of figuring out whether we should add or multiply or subtract. Exp.first is a symbol representing what operation to take, and the arguments will be a scheme list of numbers that we get by calling calc_eval on each sub-expression. Okay, the one part we've left out is calc_apply. So the apply function applies some operation to a scheme list of argument values. In calculator, all the operations are built in, and they correspond to these four built-in operators. In other programming languages that allow different kinds of abstraction, we might have to worry about user-defined operations and names for things, and we'll get there. But for now, there's only these four things we can do. So here's the implementation. It just decides which operator we're looking at, and then carries out the combination method that combines the arguments in that way. So I've removed a bunch of the source code. We can look at the whole thing in a minute. But the basic structure is that calc_apply takes in some operator, such as plus, minus, times, or divide, and some arguments, and then it does what it's supposed to do. So for plus, it adds together all those arguments, starting with 0. For minus, it's either going to subtract all the rest from the first or negate the first, depending on how many arguments there are, etc. So part of the language semantics says that plus sums the arguments, and minus does something else, and times and divide, and all of those have corresponding source code in the implementation of calc_apply. Okay. So let's look at these. Calc_eval, we saw almost all of the details of already. The only difference is that we call simplify in order to turn 8.0 into just 8. And we write out a string for the type error. But calc_apply has more going on. So let's look at the whole thing. And at the same time, we can run some examples. So if the operator is not a string, then we should complain. Type error, 2 is not a symbol. If the operator is plus, then we reduce starting with 0 and adding in everything else. If it's minus, then if there are no arguments at all, we should raise a type error. Otherwise, if there's only one argument, we should negate it. -2. Finally, we reduce by subtracting all of the rest of the arguments from the first one. So if I start with 10 and then I subtract 1, 2, and 3, I end up with 4. Multiplication just reduces the list of arguments using multiplication as a means of combination, and division is very much like subtraction. We can't divide nothing, we can invert a single argument, or we can divide out of 1024 a bunch of numbers, and so dividing out to 5 different times gives us only 32 remaining. Otherwise, we should say that something is an unknown operator. Question mark is an unknown operator. So we've covered all the cases here using calc apply in order to do all the work of figuring out how to apply an operator.